Hi, welcome back to class 8. Not 8th class, class 8 of chemical kinetics. In this session, we'll be discussing the first order reaction important formula. First order reactions are very important because first order reactions never go for completion. Remember this point, they never go for completion. If you are doing any work, okay, which is with first order completion, then that never go for completion. If your dad asks or if your mom asks, when is your chemistry syllabus is going to complete, then you just say them, I am preparing in first order kinetics. Okay, now then they will ask you when the syllabus is going to be completed. Then you ask your chemistry sir. Okay, so never go for completion. First order reactions never go for completion. The formula is K is equals to 2.303 by T log A by A minus X, where A is initial concentration of the reactants. A minus X is the concentration after T time. Okay, whatever the time is there after T time, that is A minus X. T is time, K is rate constant. We know about that very well. Then coming to other formulae, this equation what we have just now seen, okay, now is can be given in terms of this A minus X is equal to A to the power of minus kt. These are all other formulae, or X is equals to, all these are other formulae, mathematics terms you can say. Ct is equal to C naught E minus kt, where C naught means initial concentration, Ct means concentration at T time. If they're asking you in some other terms, you can say this. If you are a mathematics student, these are very easy. If you are a biology student, not required. Simple. If you are a biology student, not required. MPC student, this is not a big thing for you. From the above logarithmic equation, that is K is equal to 2.303 by T log A by A minus X, it can be shown that the graph drawn between log A minus X and time will be a straight line with a negative slope, that is equals to K by 2.303. This is the slope, negative slope. Okay, so slope is equals to minus K by 2.303. That graph also we'll discuss in detail. So half-life is T half, T1 by 2. T half is equal to 0.693 by K. 50% reaction can be done, and this is one very important formula that you need to remember. K is equal to 0.693 by K. How it is gone? T half is equal to 2.303 by K log of initial 100, completed 50, log 2. Log 2 is nothing but 2.303, log 2 is 0.3010 by K. This is nothing but 0.693 by K. When it is required, I give you the derivation. Otherwise, if I am skipping, that means that is not required. Simple logic you apply. With 23 years of rich experience, I am saying. For a first order reaction, the time taken for half change or the time taken for a definite fraction of the reaction to complete is independent of initial concentration. T half is equals to 0.693 by K, where K is the rate constant. Since K is a constant for a given first order reaction at a constant temperature, T half is a constant for a given first order reaction and is independent of the initial concentration. Very simple. If T half is, let us say, 50 minutes, if 100 gram of compound is taken, that means in 50 minutes of time, 50 gram will be consumed and 50 gram will be left. 50 gram over. These kind of questions are very common. And if you are using again 50 minutes, in this 50% is over, that is 25 grams left. Already 50 grams are over, plus 25 grams, that means 75 grams over. Completed, total completed is 75 grams. In this particular step, completed is 25, overall 75. Again, if you are taking 50 more minutes in this half, that is 12.5 grams left. And again to this you can add 12.5, 87.5 grams. Till now it is over after 3 half-lives. This is T half, this is again T half, this is one more T half. So these kind of questions are very common questions, and of course very important questions too. I told you I will give you some graphs here. You can see the graph. This graph is rate versus A minus X. A minus X is remaining concentration, that is directly proportional. Slope is K. Log A by A minus X versus T graph will be like this. Slope is 2.303 by K. Okay, this is taken from, Okay, k is equal to 2.303 by t log a by a minus x. From this expression, this graph is taken. Log a by a minus x versus t, 2 by 303 by k. T half is independent of initial concentration. For that purpose, we are showing this one. T half is not dependent. T half is proportional to a to the power 0. In zero order reaction, we were discussing a to the power 1. Okay, now for zero order reaction. For this is it a to the power 0. And concentration of reactant, it should decrease along with time. It is decreasing. Rectangular hyperbola graph, it is decreasing. If you want to take natural logarithm, then it is a straight line with negative slope. Okay, these are some important lines. Coming to two more lines and two more points we'll discuss and we'll conclude this part. All radioactive disintegration follows first order kinetics. All. Hence, the half-life of a radioactive element is independent of the initial amount taken. Based on this, so many questions you can expect. For a first order reaction, the time taken for 3/4 change is twice the time of the half change. Just now we were discussing 100 grams. If you are taking 50 grams, will be over. Then 25 grams in that over. So first 50 grams over. After second half-life, 75 grams over. So for the completion of 75%, you need 2 T halves. Half-life 1, half-life 2. Okay, few more formulae are there, like 50%, T 75%, T 87.5%, 1:2:3, T 90%, T 99%, 99, sorry, then T 99.9%, T 99.99% if you are taking 1:2:3:4. Like this, some shortcuts are there. We'll definitely discuss these shortcuts while solving questions. We'll meet in class 9 with second and third order reactions. Coming soon, class 9. Signing off, Lucky sir.